So this is 8.5 continued. We are solving complex fractions. So the first thing you need to know is there is a couple sets of fractions here. You have a numerator and denominator here. You have a couple numerators and denominators here. But you also have the big numerator and the big denominator. So we're going to have to get those to have like denominators. First thing we're going to focus on, if you look at the first fraction in the numerator, it's just one fraction. We don't have to worry about like denominators. It's only one fraction. But if you look at the bottom, right here, we see we have a 3x and an x plus 1. But we have to get them the same. So we have to use the same process we just used in the first section of these things. We have to get common denominators. What do we do? What do we do? You have to use Mr. 1. How do you use Mr. 1? What do you multiply by, guys?
By the bottom up.
Good. So we're going to multiply the second fraction by 3x over 3x. Same thing, guys. And x plus 1 over x plus 1. And we are going to simplify. So I'm going to write the numerator fraction in red. So 2x over x plus 1. And we are not going to do anything with that for a minute. We are going to solve the denominator, which I'm going to write in blue. So you're going to have to distribute the 1. So you're going to get x plus 1 over 3x times x plus 1. Plus, again, you're going to have to distribute the 2. Just once. So it's 6x over 3x times x plus 1. Right? Now what? Yep, not yet. Got common denominators. What do we do down here now? What do we do down here?
Combine them.
Combine like terms. So again, I'm going to leave my red numerator alone for just a minute. And then the denominator, we'll combine 1x and 6x's to give me 7x. The 1 does not have a like term. And then we have 3x times x plus 1. Now we are going to do keep, switch, flip. Now we're going to do keep, switch, flip. So that means we keep the numerator the same, 2x over x plus 1. We switch it from a division to a multiplication, and we flip. So this is getting flipped, the denominator. So the 3x times x plus 1 goes in the numerator, and the 7x plus 1 goes in the denominator. Now you need to see, is there anything you can cancel? All right, so your x plus 1s cancel out. You have to multiply the 2x and the 3x. This gives you 6x squared. And then in the denominator, you just have 7x plus 1. This is your answer. All right, this is example 4, simplifying complex fractions. If you notice in the denominator of the fraction, these are the same. So we can simplify this by saying 8 over 5x, all divided by, collect like terms, 1 and 4, 5, so x plus 5 over 15. We are now going to employ the keep, switch, flip. So 8 over 5x. This turns to multiplication. So we kept the first one, we switched the sign, and we flipped the bottom fraction. And then you simplify. 5 goes into 5 one time, 5 goes into 15 3 times. And you multiply. 3 times 8 is 24. And x times x plus 5, and we're going to just write that as x times x plus 5. Call it done. Here you'll notice when we have the numerator fraction, it has common denominators. The denominator fraction also has common denominators. So we can simply combine like terms if we have them. So here's our fraction bar. And in the numerator, we have 6x minus 1x, which would give us 5x. They have common denominator, so it's all over 4. In the bottom, we have an 8 plus a 3x. I just like to write that as 3x plus 8 because they're not like terms. You can't combine them. All over 2. Now you have to use keep, switch, flip. So we keep the first fraction, 5x over 4. We change it to multiplication, and we flip this second fraction. So the 2's in the numerator, and the 3x plus 8 is in the denominator. Then you simplify. 2 and 4 can reduce. 2 goes into 2 one time, 2 goes into 4 twice. You multiply straight across. So 5 times this 1, 5x times 1 is just 5x. 2 times 3x plus 8, you must distribute, so 2 times 3x gives us 6x, and 2 times 8 gives us a plus 16. There's our answer. Okay, last problem of the day. We are going to have to get common denominators on both the numerator fraction and the denominator fraction. So what do you want the common denominator to be? Can you make it more simplified? Not quite there. Let me think. If this is 2x, this is 2x, and this is x squared.
So you can have that by x and that by 2.
So 2x squared. There we go. We want the denominator to be 2x squared. So this needs an x over x.
Oh, you asked
What it would be.
Oh, okay.
Yeah, what it would be. And then if you went crazy, but we're going to not feel crazy. Not yet. So this will give us 5x over 2x squared plus 14 over 2x squared. Right? Looking at the denominator, we also need to get common denominators in the bottom part of the fraction. And it happens to be the same denominator as the numerator used. So we're going to multiply the first one by 2 over 2 and the second one by x over x. That's going to give me 6 over 2x squared minus x over 2x squared. Now what should I do? Not yet. Not yet. Not until we have one fraction divided by another fraction. We'll get there. Combine like terms. So combine like terms gives me 5x plus 14 over 2x squared divided by 6 minus x over 2x squared. Now we have one fraction divided by another fraction. This is what we keep switch flip. So we keep 5x plus 14 divided by 2x squared. Switch the sign, flip the second fraction, so 2x squared over 6 minus x. See if you can reduce and or simplify. 2x squareds cancel out. They absolutely do. Which leaves us with what?
5x plus 14.
What would happen if I wrote it like this?
It'll just be on my bracket.
It'd be a standard form.